Hello, everybody. Welcome to my talk, Build the API That You Want to See in the World. It's going to be very inspirational. Okay, so I am a software engineer at Condé Nast International in London. As they said, I organize No Girls, and I also love GraphQL, as you will discover. And if you want to tweet me things about GraphQL, you can do so here. So yeah, I'm going to be speaking to you about GraphQL. And I want to warn you that I'm going to say the word GraphQL a lot, so you've just got to roll with it. And this isn't going to be a 30-minute introduction to what GraphQL is. This is going to be a talk about the problems that GraphQL can solve. I'm going to talk about why I used GraphQL in my project, and also what are some of the good use cases for GraphQL if you're thinking about trying it out for yourself. So yeah, we're going to talk about my GraphQL story and some general use cases, or what could be your GraphQL story. But first, we're going to do a quick GraphQL 101, just so you'll know what I'm talking about. So GraphQL, if you go to the website, it will describe itself as a query language for APIs. Or my friend Alex describes it as a language for requesting remote data. Or you could also call it a syntax for asking for information or data from a server. And it's often compared to REST, so I'll talk about a couple of the main differences between GraphQL and REST, if you're used to REST APIs. So with REST, you tend to have multiple endpoints which represent different resources. So for a media website, you might have an articles endpoint and a galleries endpoint. And the articles endpoint will give you article data, and the galleries, etc. GraphQL only has a single multi-purpose endpoint. It might be /GraphQL. And this endpoint is going to give you all the data that you need in your application. With REST, the endpoint is going to give you a predefined set of data for that endpoint. So the articles endpoint will give you a set of fields that you'll pretty much always get for an article. And you don't have any say in what fields those are. GraphQL, meanwhile, will give you exactly the data that you ask for, no more and no less. So you can control what fields you get back from the API. There's a schema in GraphQL that tells you all the fields that you can request and their types. And then when you want to request these, you write a query that describes what you want. So you basically write like a shopping list saying, I want these pieces of data, please give them to me, GraphQL. So let's get into my GraphQL story. And I'm going to give you some context to the project that I'm going to be talking about. So I work at Condé Nast, and we are a publisher of various magazines, and we represent some brands that you've probably heard of, such as GQ and Vogue. And GQ, unfortunately, is not a magazine about GraphQL, even though I would like it to be like high fashion GraphQL. No, it's a magazine about men's lifestyle and fashion. And my team works on the websites for these brands. So this is the beautiful Vogue Germany website that my team built. And it is currently powered by GraphQL. And I'm going to tell you about how we got there, because that was not always the case. So here's a bit about what our app used to look like before GraphQL. And I'll tell you that we're using an API for the content management system, which our editors use to write their articles. So I'll use the acronym CMS, that's what I mean. We use an internally built CMS, obviously, called Copilot. It's a Node CMS, but you can just imagine any CMS of choice. And our application looked a bit like this. So it's a Node and React app. We spoke directly to that API. We stored the data from that API in a Redux store, and we were server-side rendering our React components, all to render the beautiful Vogue Germany website. But we had a lot of problems after we'd worked with this structure for about 6 months. And we had a retrospective where we sat down and thought about the things that we liked and the things that we didn't like about our code base. And here are some of the problems that we came up with, and some of them might sound familiar to you. The first one is that a lot of our components were tied really specifically to the API response. And this is going to follow on really well from the last talk. So this is a dramatic example, but we might have had components along these lines where this is a title component to render the title for an article. And instead of just passing in what we need, which is the title text, we might pass in literally the entire API response for that page and then do nothing with most of that data and just access properties directly off that object, which is, yeah, not ideal. Why is this bad? Well, if the API changes, then you have to update your components. So if the API developer changes that property from title to head, then we would have had to update our component, which we should not have to. It's also less readable because it's not clear what data your component needs. So if I'm a new developer and I come to the code base and I look at this component, it's not clear to me what values I need to give this component in order to have it successfully render. And our components know way too much about their context. And thank you to the last speaker for explaining all of this. By context, I mean where the data comes from, the structure it's fetched in, and all the data that is available in the app. And ideally, we would have a few components that know about context, while most of them have no idea. The theory of presentational versus container components. So ideally, we would have presentational components that know nothing about their context. They just take in data and display it. So if we were to refactor our title component to be a bit more purely presentational and lovely, we would just pass in the text and render the text, and it would have no idea about the API. And then there are the container components, which know about context and provide data to the presentational components. And an example from our code base of this would be an article page. So you can see we're getting the article data from a higher order component with article data. And then we have all that data inside the article component, but then we only give the data to the smaller components that they need. So the title just gets the title text, the byline just gets the author. So this is all beautiful, but unfortunately, we did not enforce this strictly enough in our code base, and a lot of our components knew way too much about the context around them, and this was a problem for us. In an ideal world, even the container components would not know about the third-party API. More on this later. Basically, our components needed major refactoring. Problem number 2 is that we sent a lot of data that we weren't using to the client. So this beautiful GIF shows all the article data that we got back when we tried to hit the article's endpoint. And as you can see, there's a lot of data in there. And I'm very sorry to say that even though we used probably less than 50% of it, a lot of it ended up on the client in our Redux store. Why is this bad? Well, first of all, it's a lot of confusing clutter because we don't need this data, so why is it there? It's just confusing to try and sift through all that data all of the time. It could also affect performance because the browser is downloading unnecessary stuff. And it could be a security risk because what if the API developer introduces a sensitive field like password? And because we're sending the entire API response to the client, we've now exposed a password to the people reading Vogue. Moral of the story is that we should not be sending all of this data to the client, and that is bad. Another problem we had was that if we were to switch data sources, we would have to completely rewrite our entire application. So pretty much everything in our application was closely tied to this content management system API. And that's from the components that I showed you in the first issue, but also our analytics and our metadata, and even our server route handlers. So if we switched content management system, we would pretty much have to throw away our app and completely rewrite it. So if Condé Nast wanted to switch to WordPress, that would be a problem for us. So yeah, if our beautiful pink API changed to a rainbow API, our app implodes. Why is this bad? Well, technology changes, and your application should be resilient. And if you're on a commercial project, it's a business risk to couple your application so tightly to a third-party service. We needed to consciously decouple. Niche joke. The fourth problem we had was that the API was difficult to work with, and it had some quirks that we did not understand because we weren't the ones that built this API. And as a disclaimer, and I'm not just saying this because the CMS was built by Condé Nast US, this is the case with all third-party APIs that you will use. And I don't think the API that we used was any better or worse than most APIs out there. It actually wasn't that bad. But there are some problems that you will commonly experience when you're working with third-party APIs. Mainly because it was not built with our specific use case in mind. Outrageous, I know. And here are some of the problems that we experienced. So field names did not always make sense to us. Some of them were some really specific publishing jargon that would always confuse newcomers to our code base. There's also so much data, way more than we needed, as evidenced here. And some of the data was not in the format that we required. Once again, outrageous. The body of an article would come back to us in Markdown, which I'm sure is very convenient for the content management system. But for us, it was quite inconvenient because we had to convert Markdown to something that we could render on the page. So there was a lot of additional effort that we were doing. There's also not always documentation, common API problem. Documentation is hard when it's done by humans, as we've heard. And third-party APIs will never be perfect. But we needed to work with the API in a better way inside our application to minimize the impact and the stress that it was causing us. Final problem is that we were fetching data in really complicated ways from deep trees in the API every time, which just as a sentence really stresses me out. So let's take an article about Meghan Markle. I don't know if she's a big deal here, but she's a big deal in the UK, especially for Vogue readers. So if we want to render an article about Meghan Markle, these are all the requests that we would have to make. So first we look up the Meghan Markle article, but then we also have to look up the publish history to get some specific publish dates for our analytics. We have to look up the contributor, Michelle Garret. I hear she's fascinating. We have to look up the fashion category to find out more about that. We have to look up the recommendations because we show recommendations at the bottom of an article. But that endpoint only gives us a list of IDs. So we then have to take those IDs and look up every single one of those IDs individually to get all the content. And then we have to smush it all together in order to render the Meghan Markle content. Why is this bad? Well, first of all, as you might have just experienced, it was cognitive overload trying to remember where to get which data every time that we needed it. And we had to navigate really complex relationships between objects, like with the recommendations. We would have to look those up and then embed those objects. It was a lot. And generally, we just had to make multiple requests in our main application to get the data we wanted when we wanted it, which for us was mostly just confusing. But if you make multiple requests client-side, it is not performant. Thankfully, we were server-side rendering, but this would be a problem for some people. It's also harder to debug, because when something goes wrong in this chain of requests, it's really hard to track down where the problem is. It was a lot to deal with, and clearly we had some issues. So how do we solve these problems? So we had a spike earlier in the year where we started prototyping different solutions to improve our code base and try and solve these problems. One was a refactor of the code base based on a design pattern, domain-driven design, and the other was GraphQL. And as I'm sure you can guess, we chose GraphQL. So if you remember, this is what our application looked like before. And what we did was we essentially, all our business logic was happening inside this main application, in and around all of our React components. Then we added a GraphQL layer in between the React app and the third-party API that we were using. And essentially, all the business logic moved into this GraphQL layer, which essentially shielded the rest of the application from all of this really complicated business logic. So what did GraphQL give us? Firstly, it gave us instant documentation, because the GraphQL ecosystem has some tools that generate documentation from your schema. Some of them are called GraphQL or GraphQL Playground. Here's a screenshot from GraphQL Playground. It's kind of like Postman if you've used that for REST. And there's this nice little tab on the right which pops out and shows you the whole schema. It'll show you all the different queries you can make. It'll show you the arguments that you need to include to make those queries and which ones are required and their types. And it will also show you the data that you can ask for. So basically all the fields and the types of all those fields. And if they're more complicated types, you can click through and see the types of those. It's a beautiful thing. And our documentation is now actually useful and stays up to date with no effort. And we now know for sure what data we can request for our client-side application, which is a big step up from what we had before. Another benefit is that we no longer have to fetch data with multiple requests inside our main application. So if you remember the Meghan Markle incident from earlier, now, instead of making all those requests, we make a single query. We write a list of the data that we want. So say we want the ID, the body, the tags, the categories, and various other things. We want the recommendations. And it will give us that data, no questions asked, like a shady deal. But it will just give it to us all in one go, and we don't have to make all those different requests. So now we get the data in a really clear and consistent way inside our React app. And I will say that we do still have to make the same requests, but these requests now happen in the GraphQL layer, and our React application doesn't have to know about it, and we don't have to constantly think about it every time we want to get data for a component. And our lives are now a lot easier now that we only have to think about a single query when we want some data. Another benefit, which I didn't really expect, but is a huge one for us, is that it encouraged good patterns of structuring our app. And obviously, good is subjective, but here's what that meant for us. It meant that we started fetching only the data that we needed. We stripped all the business logic out of our components, and finally had some true separation of concerns inside our code base. We used field names that actually made sense to us instead of using what the API gave us. And most importantly, our UI is no longer tied to this API. As a disclaimer, we could have done this without GraphQL, because if we were more disciplined developers, we could have avoided some of these problems in the first place. We could have just written our components in a better way. Because there are programming patterns that encourage these principles, like domain-driven design or hexagonal architecture, which are some of the ones that we explored. But GraphQL enforces these patterns without requiring developers to police it themselves. And we found that GraphQL allows us to follow these patterns without having to think about it. Another benefit is that we now have the assurance that if we ever need to change our data source, most of our application will not be affected. So in our scenario of Condé Nast deciding to switch its content management system to WordPress, it'll look like this. So because we have this GraphQL layer, when we switch out to a Rainbow API, WordPress, the React app has no idea because this is all handled in the GraphQL layer. Changing data sources will only affect the GraphQL layer, which is effectively shielding the React app. And the impact is limited to updating the functions that resolve the data for each field in the schema inside that GraphQL layer. So the API we use might be completely rewritten, but our application is resilient. And we can now react more easily to technology changes, and our application will not be devastated in a way that it would have been 6 months ago. So this is why I'm so obsessed with GraphQL and what it gave us in our application. But I'm going to give you some use cases that I think are compelling. So GraphQL won't fix all your problems, but I think in these situations, it would really help. The first situation I see is that you have a set of data that needs to serve multiple applications. So this might look something like this, where you might have 2 applications, let's say the Vogue web app, and then also a Vogue native app. And they both need to use the same API, which is the Content Management System API. I think that GraphQL is product friendly, by which I mean It has a lower barrier to entry for new consumers to an API because it reduces the burden on consumers to perform logic. So in a previous life, maybe we would have done something like this. So the website and the native app would speak to the API individually, and the business logic would take place inside both of those applications. But if you have a GraphQL layer which sits in between the API and those applications can speak to GraphQL instead, all the business logic can happen once inside the GraphQL layer. So all the logic of making 7 Meghan Markle requests can all happen inside the GraphQL layer in one place, and we don't have to repeat that multiple times. So it's easier for new applications to get up and running. GraphQL also does not enforce a specific way to consume an API. So it gives consumers the flexibility to request the data in the way that they want it. So say we want to render a beauty page for the Vogue website. We could write a query like this. So we want to look up the beauty category, and we want 10 articles, and we want a title and an image for each of those articles to display on the beauty category page. That's beautiful. We've just described what we want. But then in the native app, we also might want a beauty category page, but instead of articles, we want images. And because we're using GraphQL, we're not going to be burdened with all the images that we needed for the website. We can just say what we want, and we'll only get what we actually want. So your applications can be totally different, but seamlessly use the exact same set of data. Another use case is that you're building an application that uses multiple data sources. So in this scenario, Condé Nast might introduce an extra data source, like a shoes API for a feed of shoes on the homepage, which is a feature that I'm pushing for. So in this case, we have the Vogue website, and we have 2 APIs that we need to speak to. And in a former life, we might have to do all the logic inside our main application to talk to those 2 different APIs, and we would be very aware of that. But you can build a GraphQL layer to fetch data from all of these different data sources, combine data from anywhere, but only interact with one interface. And I want to say that GraphQL and REST are not mutually exclusive. What I've described today is essentially adding a GraphQL layer on top of a REST API in order to interact with it in the way that you want. And you can get data from lots of different places, including REST APIs, and smush all of it together. So you could get data from REST APIs, other GraphQL APIs, a database, a JSON file in your file system, a random S3 bucket, wherever you want, a tweet, I don't know. Let your imagination run wild. But this is what it would look like if we added the shoe API. So our React application is interacting with the GraphQL layer, and it has no idea that behind the scenes, the GraphQL is speaking to 2 different APIs. All the React app knows is that it can get shoe data, and it doesn't really care where it comes from. It just knows that GraphQL can give it to it. And all of your resolver functions are going to handle the complication behind the scenes. So all the logic will be in there. Meanwhile, on the front end, you're living the sweet GraphQL life. So a third use case is that you want to enforce structure in your code base. Good is subjective, but I think GraphQL encourages good habits, and it will help you to separate your concerns. It will encourage you to remove logic specific to third-party APIs from your client application, which I think is great. Another use case is that you've built your REST API like a pseudo-GraphQL API anyway, by which I mean, do you have endpoints that fetch fields based on a query param? You might have seen this in some APIs. Like an articles endpoint, where you can give it the slug, Meghan Markle, but then there's also a query parameter where you can specify the fields. So say I want the title, the author, and the body. If this looks familiar, it's because it's basically already GraphQL. And I feel like you should lean in and just make it GraphQL. The final use case, I think, is because it's fun and everybody else is doing it. And I know that this is not the only reason that you should choose a tool, but I think that combined with all the other amazing benefits of GraphQL, I think it's a good one to add into the mix. And I'm not sponsored by GraphQL, I'm just a really big fan. And that's all I have to say. Thank you. If you want to tweet me, you can do it here. And I'm going to let you know that I also have some really deluxe stickers which say my code is in vogue. So if you would like one of these stickers, come and speak to me or confide your GraphQL worries in me. Thank you.